So from now on, class is going to be very, very interactive. When I mean interactive, it's like there's going to be more and more theory. Like I'll be teaching theory, right? I'll be teaching all of this theory. Like we're doing this theory, speaking. So I want you guys to ask questions. I want you guys to ask a lot of questions. Don't just let me speak. Ask a lot of questions and feedback and ask questions. If you don't understand something, ask lots of questions, because this is your main job. Everything you see here, these 8 chapters, is your main job. This is your main job. The SRE in a production environment. If you don't know what production environment means, ask me. If you don't know what issue debugging means, ask me. Anything that you don't know, this content here, this is your main job. This is what we're going to go through. This is the meat and potatoes of what you're going to be doing Monday to Friday, 9 to 5. This is it. Everything we've done was just the fundamentals to get to here. However, we are not done with all the fundamental, but due to time constraints, we have to keep moving forward. We've done networking, very, very deep networking. We've done some security. We've done some compute and Linux work, right? We haven't done Windows. We've done some Azure, AWS. We haven't done Google Cloud. I'm aware, right? I gave you guys some project on CloudWatch installation. If you haven't done it, we're going to push it to the weekend project. So the things that you haven't done as an assignment, homework, you can do it together on the homework in the weekend. Those who have done it and successfully did it will have to share their screen on Saturday and show it. For example, Kwasi did the CloudWatch installation on EC2. So on Saturday within 2 to 4 p.m., he may share his screen and show it. You would join the same Zoom link, right? And then you guys will work together as a team. Okay. Any suggestions or questions on how this is gonna go? Anybody can share your screen. There are other projects that Kobe completed, the installation of a web server, the LAMP stack. Elvis also completed that project as well. So if those kind of projects come up, they can also share their screen and complete them as well. Isabel did some Linux networking, Linux work as well, so she can also share her screen as well. Anyone who knows that topic very well, please volunteer to share your screen and work as a team. This is very important because when you start working, you'll be working as a team. So you better start building those team skills now. You will experience some people have attitude, some people don't want to work with you, some people have attitude. It's the same thing you're going to experience in the job. So it's better for you to start building that experience here among yourselves before you go in the real world, in the Geicos, in the big companies, the governments. You're going to experience people with attitude, right? So it's better you experience it here now and learn how to deal with it before you get out there in the real world. Trust me, you have some very difficult people in your group that you don't know about. I'm not going to call no names, but you will see. So what is IT? What is information technology? IT, right? IT is an application of technology to solve specific or organizational problems on a large scale or to serve a purpose. So Priceline, everyone know Priceline.com? Priceline is a company that you use to book travel. Priceline.com. This site, you use to book travel, right? This is what you use to book travel. So but it's not just a website, it's a platform. You can sign in, you can book hotels, flights, you can bundle and save. So it means you book hotel and flight, you bundle, and you save some money because you bundle. You can rent cars, you can rent cruises, right? You also have some coupons, some deals, kind of QR code. So it's a platform. You have pay. This Affirm is, if you don't have money to travel, it's like a credit card for expenses. You can book a travel that costs $3,000, and with Affirm, you pay $300 a month. So the $3,000 that you spent travel to Dubai, with Affirm, you can pay $300 every month until you pay the full $3,000. So you can do 10 payments of $300 every month. That's what Affirm is. So this Affirm is a different company, right? Affirm is a different company. Buy now, pay later, right? A different company on its own. It has its own website. but they were able to integrate Affirm with Priceline. So that's why Priceline is a platform. It has many, many integrations with Priceline. Also, you have something called Stripe. Stripe is a tool that allows you to collect payments like this. You put your credit card number like this and you collect payments. Since Priceline, when you have an account, you're able to go in here, book your hotel, and you pay with your credit card. They also have Stripe integrated into this platform. Then we'll also talk about AVI, address verification, right? They also have that integrated here as well. So that's what makes this a platform and makes this a big, big company. So IT is trying to solve a specific business problem on a large scale. So the problem of buying travel, before in the 90s, you had to call 1-800 travel, 55555 and say, I want to go to New York, I need a flight on this and that. And then they'll book it for you online over the phone. American Airlines will book it over the phone, they'll book it for you over the phone. But nowadays, you can go online and buy it yourself. So Priceline has used information technology to solve the problem of buying or travel over the phone online. So they've solved that on a large scale. Now you can buy flight and hotel together. You can bundle flight, hotel, and car, and you save money. So that's Priceline solving the problem on a large scale. The purpose can be for entertainment purposes. Before you were in Netflix, you had to go to a gas station in Netflix and go and get the physical CD and come and watch it at home, right? A physical disc and put it in your deck or your, what they got, Blu-ray player or your PS5 or your Xbox, right? Now you can watch Netflix online. You don't have to go and buy any disc anymore. All those movies that sell at Target, those DVDs are gone. So that's IT. Netflix use IT to solve a specific business problem. Hulu, Prime Video, right? E-commerce. Before you had to go to the store to buy tomatoes, onions. Now you can just sit down and order things from DoorDash and it comes to your house. So that's using IT to solve a business problem. Medical services. You can order your medication on Amazon Pharmacy and it comes to your house. Telecom, right? Telecommunications, right? Phones and everything. Now we don't have fixed phones anymore. We have mobile phones. That's IT being used to solve specific problems, right? So productivity and efficiency improvements, right? So now we're able to be more productive. We have cell phones, we have apps that makes us more productive and efficient. And then globalization and bridge cultural gaps. So, Cameroon did not have phones before. Cameroon did not have credit card readers before. Now we collect credit cards in Cameroon. Now you can buy gas at a gas station using your credit card, right? So that's globalization of all these things. So IT represents cloud, which is AWS, Azure, GCP, represents networking, which we have done, cybersecurity, which is security of the network, right? And then databases is where the data is stored, right? And then you have the hardware, which is the physical CPU, the physical machines that we use. Then you have devices, mobile devices that are used to connect to our applications. You have the applications themselves, which is the Priceline.com, Amazon.com application. It's actual application that solves a specific business problem, right? People buy flights on there. That's an application. Then you have support, which is us. This is us right here, right? So support supports all these things as much as we can. We cannot support mobile devices. We'll support the application. We'll support the cloud, whether it's AWS or Azure or GCP. We'll support the network. We'll support cybersecurity. We'll support the databases. We'll support the hardware. If we're in the office, we'll support the hardware. If we're not in the office, then we cannot support the hardware. We can support the software, which is the operating system in this case. So that's what IT stands for. This is what you're getting into. What is this thing bothering me here? Log off. Okay. Please ask me any questions if you do. So types of IT companies, this is a very important one too, because this will determine where you work. This will determine where you work. You're going to work in one of these three companies, guys. I work for all three of them, right? So let me explain. All these companies, one of you work one of those companies. Amen? Can I get another amen? Can I get another amen?
Amen.
One of you are going to work one of these companies. Maybe Facebook or, I don't know, LinkedIn is a good company. LinkedIn is a good company. They pay well, actually. They better than pay, they treat people well. As a key thing. Treat people well. Pay is not just about pay. You can pay people well and treat them not nice, but they treat you well. Like when you guys have a happy hour or company outing, they really go out. They go luxury. They really go luxury. That one I can attest to that. LinkedIn is a good company to work for. Product company is a type of company that creates and deliver the product to a wide range of customers. They create products. For example, who can give an example of a product company? I want to be interactive. A product.
Apple.
Sorry?
Apple.
Thank you. Apple creates what?
Cell phones. Apple cell phones.
No. Apple creates what? Apple doesn't create cell phone. What does Apple create? Come on now.
Machine.
Yes.
What is the name of Apple product?
Okay. iPhone.
iPhone. Come on, guys. Come on, guys. Come on now. Guys, wake up. Let me give a little exercise. Let's wake up. Let me give a little exercise to wake your brains up. Let's do that right now. Okay, let's do this. If X is equal to Y, then Y is equal to what? Hello? If X
X.
equals to, if X equals to Y, then Y is equals to what?
X.
What was that?
X.
Yes, X, correct. Okay. If X X times X is equal to X, and then where's that character? If X times 2 is equal to X squared, then Y times Y is equal to what?
Y square.
There you go. Y squared. Okay. Which one came first? Which one came first? The egg. 2, the chicken. Which one came first?
The egg.
Why?
The chick.
Because it's number one, like it's in order 1, 2.
Okay. I like that, Isabel. I like that. I like the way you're going. Okay, let's do this.
The chicken. For me, I think the chicken.
Okay, hold on. No, Isabel was right. Okay. Let's do this way. Which one came first, the egg or the chicken?
Are you want to say which one existed first?
Yes, which one existed first? Yes.
The chicken.
Chicken.
How was the chicken born?
That
Two eggs.
The egg.
the
Where's
egg
the
came
egg?
from where?
And it's the chicken that laid the eggs.
And the
It's
chicken came out
later.
of the egg.
So this is a problem that has never been solved. We can argue here for 10 hours. There's no solution. It's called the chicken and egg problem. If you Google it, if you Google it, it's called the chicken and egg problem. It has never been solved. It's a cause and effects are unclear. The chicken laid the egg, but the chicken was born from the egg. So it will never be solved. It's not one of those that will never be solved, and that's okay. So I want to just bring you guys your brains back to straight, right? So a product company creates and delivers the products to a wide range of customers. Apple creates iPhones. The reason I say so because a telecommunications company creates cell phones. Telecommunications company creates cell phones. Apple creates iPhone, which is also a cell phone because Apple is a telecommunication company. But in the hindsight of things, as a technical person, your mentality, the name of Apple's product is iPhone, is MacBook, is AirPod, is AirPods. That's how you should look at it. But in the telecommunication industry, telecommunications companies produce cell phones. Cell phones is a general category of things. Telecommunications is a general category where all telecommunications companies fall under. So similarly, cell phones is a general category where all types of cell phones, iPhone, Android, Google phones fall under cell phones. So when they say which product does Apple produces, your answer should be iPhone, MacBook, AirPod. Which product does Google or Samsung produces? Which product? Okay, let's see. What does Samsung as a company produce?
Laptops. TVs.
TV,
Telephone.
phones,
Phones. So
Red
Samsung normally we say produces how do they call it?
I don't think we got
Android
it.
phones.
You just said phones. You just said laptops. That's a general.
That are general terms, right? That for what they produce,
Exactly.
right?
So what product does Samsung produce?
Samsung phones,
There you
Samsung,
go. Samsung phone, Samsung laptop, Samsung headphones. Okay, what products does HP produce?
HP laptops.
Thank you. I'm trying to get you to attach the name of the company to each product. They are tied together. A product company creates and delivers the product to a wide range of customers. You don't want to be general, you want to be specific. If you want to go work at LinkedIn, what does LinkedIn produce?
Provide service.
So what is LinkedIn? It's a service
Service.
implementer.
Mhm.
So what services does LinkedIn offer?
Networking. Career like professional networking.
social media.
You guys, that's a general terms. LinkedIn provides LinkedIn networking. LinkedIn provides LinkedIn jobs. LinkedIn provides LinkedIn career building. LinkedIn provides LinkedIn education. Are you guys listening? Like you have to tie the service to the thing that is happening. If you go to LinkedIn, you can go to LinkedIn jobs. You can go to LinkedIn networking. It's a specific service. This is a tab right here, service. You can go to LinkedIn learning. This is a separate service they provide. They provide LinkedIn learning. That's what I'm trying to get at. You need to know what the company is selling or how the company makes their money before you even apply to go work for them. Because if you go to an interview, they're going to ask you, do you know what we do? Do you know how we make money? You need to know these things, guys. Let's pick another company here. What does Facebook provide? What kind of company?
Services,
Okay, what kind of services Facebook provide?
advertising services.
You're still going general again. How about you say Facebook advertising? That's a
Yeah, that makes sense.
thing.
Yeah.
Facebook Marketplace, Facebook dating, Facebook groups, Facebook Messenger. You have Facebook WhatsApp. You have Instagram. It's specific to Facebook. Are you understand how I'm coming from this? Guys, it's important because you have to know what the company is selling and what the company is providing before you can become an SRE to support them. You will know how they make money, and you also know how if something happens to their system, they go down, you know the impact because you know what they do. If Facebook groups go down and you work for Facebook, you know that, okay, those groups, Jangi groups, and football groups, and social media groups that do Kongosa are affected because you know the products that Facebook offers. It's important to know the products that the company do. Let's pick another company. Last one. What does the New York Stock Exchange, if you guys are aware of that, I don't know. Or what does Microsoft provide? What kind of company is Microsoft? Microsoft, you guys use it every day. Some companies can do both. Some companies can be all three of these. Some companies can have products and services. Some companies have products, services, and consulting.
Yeah, Microsoft provide services.
And what else? Microsoft
I think they provide both.
What product does Microsoft create? What product has Microsoft ever created?
The Microsoft devices, like those small gadgets that they use in communicating.
Well, Microsoft also provided products or applications like Power BI for data analytics.
Give me a product that Microsoft has created.
Sorry?
Windows.
Windows is a product?
Non-player.
Windows is a product? Is a product?
Yes.
Okay. Yes, it's a product. Windows is a product. Okay? It's a product, right? A product must not mean something physical, right? A product is something that you buy and you use. So you buy the Windows operating system and you use it, and you pay licensing every year, or you buy the licensing for lifetime, right? So yeah, Microsoft is a product company, but Microsoft also provides services as well, right? Microsoft Office 365 is a product, right? Microsoft also offers services as well, support services. If you use Microsoft Azure and your systems are down, they'll give you support services as well, right? And they also have consulting division as well. So Microsoft has all three of these. Okay. So, but again, they'll call it Microsoft Support Service. They'll not just say support, right? Microsoft provides Windows. Microsoft Windows is what they call it. Microsoft Office 365 is the name of the product. The name of the company always precedes the name of its product. You cannot just say Excel. No, it's Microsoft Excel. It's Microsoft PowerPoint. Microsoft OneNote, right? Look at right here. The product name is called what? Microsoft OneNote, Microsoft Word, Microsoft Excel, because it's Microsoft's products. So they're going to put their name in front of it. Okay? I hope our business house to that. So consulting services, so you have product companies that produce, create a product and sell, and that product is meant to solve a specific business problem at a larger scale, right? Like when Microsoft Windows is an operating system that is used to for as an operating system, right? Then you have consulting services, right? Consulting services provide feedback, support, and design and build our products. So when your consulting services are superior services that companies provide for consulting, like, okay, you run a company, Priceline runs a company, and they want to build some more functionality into the Priceline app, right? They want to add something into this Priceline app right here, right? They want to add, they offer hotel, flights, cars on cruises. Let's say they want to add boat rentals here. They're going to consult with a consulting company like Accenture or Deloitte or Pricewaterhouse. Say, hey, we want to build another functionality to add boat rentals here. So Accenture will offer them consulting services, provide them developers, SREs to join their company and help them build that additional feature into the application. Okay. Okay. Any questions there on consulting and product companies? And then lastly, service implementer, right? A service implementer is the build software. SW stands for software here. They build software or product only when customer approaches them, right? A service implementer is people that implement services. So for example, if you want to build a mobile app today, you approach me as an artist guy, say, hey, we want to build a mobile app, and we'll take your design that you have designed, all your ideas that you have done, and we'll implement it for you. That's what Accenture does. Accenture is a service implementer and a consulting company. Accenture here is a consulting company and a service implementer, right? IBM is also a consulting company, a product company, and a service implementer as well. Microsoft also does implementation as well. Microsoft is all three. Microsoft can implement services on your behalf, okay? So that's what these three companies are. So if you look at every company in the world, they fall into one of these categories, right? Netflix is a product company. Priceline.com is a product company. Okay. Priceline, Geico is a product company. State Farm is a product company. All these companies are product companies. Okay. So product-based companies identify a problem, statement, or need of the market and create a design of a product to fulfill and solve the problem. So let me take a pause here, guys. As SRE engineers, understanding the problem is halfway there. Whenever a company has a problem like an outage or something, once you understand the problem, you have halfway there in solving it. Understanding the problem is the number one thing. It's 50% of solving a problem. The actual solution to solve the problem is not even important. The problem is understanding the problem. Once you understand the problem, maybe say, let's say you understand, okay, it's the client's, it's on the client side. The client is not sending a request to the server properly, and you understand that completely, you have solved that problem. You're halfway there. You are halfway there, guys. So take note of that. Try to understand the problem. We have learned networking. We know what client is, server is, 504, 404 errors. Once you know that the issue is on the server side and it's on layer 7 or layer 6 or layer 5 or on layer 4, and you do your networking commands and you understand the problem, solving the problem will not be an issue. Okay, so back to product-based company. Product-based company identify a problem statement or need of a problem of market and create design to fulfill and solve that problem. For example, Geico, State Farm, Allstate, they sell insurance online because before you had to go into an office to buy insurance. Now you can buy insurance online, just send your ID card online, everything is online. So that's a product-based company. They had an idea, they designed the idea, they built it, and they launched the idea, right? Amazon had an idea to build cloud. They designed the cloud, they built it, and then they launched it. The idea came by Jeff Bezos, the owner of AWS and Amazon. The design came by some architects. Architects design it. Developers build it with code. And then the marketing team, the scrum masters, the project managers, the SRE people, they launch it and then they maintain it. Same thing with Tesla. Tesla, Facebook, IBM, Uber, Samsung, those are all product-based companies. Once the product is built or application is developed, it is open to the market. Product-based companies make their product before the demand of people. So they make it before the demand of people. iPhone 16 was made and then advertised, and then people started demanding for it. People did not go and request iPhone 16 to come with one extra button. No. The phone is trash. The iPhone 16 is really, really trash. So I'm going to wait for the 17. Okay? Don't buy it. Wait for the 17. Quality of the product is king. Exactly what I was just saying. The iPhone 16 is trash. It's not, it does not difference with the I have a 13. That's how behind I am. I'm on a 13. Because the quality of the iPhone 16 is bad, I have to wait for the 17 next year. Maybe my iPhone 13 will just freeze. Okay. All jokes aside, right? The quality of the product is king. So when you join a company as an SRE, you'll be held at the highest standards to maintain that quality. For example, Apple Corporation. Apple is headquarters in this. They have a big office in Austin. They have a high standard. The iPhone is a big phone. Everyone looks at Apple as a big company. So when you work there, you have to maintain the highest standards, quality. You have to be more of a quality person than a quantity person. They might not ask you to resolve 50 tickets a month, but you might have to do 25 tickets a month because they're focused on quality over quantity. Wherever at Amazon, you're required to resolve 50 tickets a month because they want quality. Amazon is all about quality, the fact, quantity. They don't really care about quality, right? So that's one thing to take note of. Uber has a head office in downtown Dallas. They have a high quality. People work there Tuesday, Wednesday, Friday. Tuesday, Wednesday, Thursday is hybrid. So if you go to that office, they will expect you to have high quality, right? That's product-based company. Any questions here? Okay, consulting company. A consulting company is a firm. It's a business comprised of industry-specific experts who offer professional advice, guidance, and actionable solutions to businesses experiencing issues. It helps organizations to improve their business performance in terms of operations, profitability, management, and structure and strategy. Focus on designing and architecting of specific business requirements from clients. I do this a lot, right? As professional experts, we're certified. We are AWS certified, we're Azure certified, we're GCP certified, we're certified in a lot of technologies. So we have professional advice. We do provide professional advice to companies about helping them with their systems, right? So companies have their ideas, but during the design of the ideas, as an architect, I will go in and help. I'll go in and help the company. Say, hey, this idea you guys have, you want to build a platform to add boats, rentals to Priceline.com. This is how we should do it. I think this is how we should do it because I think that if you come to this platform and you want to add boat rentals here, well, you may not have enough boats yourself, but there are people in Miami, in Tampa that have boat rentals. So those people, let's create a platform for them where they can put their boats online. They can put their boats online. And then when they put their boats online, we can now integrate their platform to this so that they don't have to upload their boats on Priceline.com. They'll put their boats on that side and then we'll pull an API and push it here, right? because boat rentals is not like American Airlines or Delta Airlines that, it's just there like that, right? So there's no known platform for boat rentals. So Price Locker will have to figure out where would the supply of boat rentals come from, right? Where would that supply come from? So that's one thing that the architects will design to help them to design the supply of where the platform where people can list their boats and things like that, right? Okay. So consulting services, we come in and help with the design, and then we'll work with the developers who build it, and then we'll launch it. Accenture is one of them. KPMG is one of them. Hitachi, Deloitte, PricewaterhouseCoopers, Wipro, Bain & Company, Marsh & McMillan. Infosys is a big company. Lots of Indians work here. BMC, Tata Consulting Services in Detroit, Sapient Consulting, right? So if you want to work for these consulting companies, I would say the best ones go to Deloitte, go to Accenture, right? Go to PwC. They call them the Big Four consulting firms. Accenture, the Big Four is KPMG, Deloitte, Pricewaterhouse, and I think Accenture are the Big Four, right? Those Big Four. That's what they call them, the Big Four. So are the Big Four consulting companies to work for. Any questions on consulting companies? Okay, then lastly, you have the service company. The service company builds software. They don't build any products. They don't build any hard product, right? They build software or application exclusive to the customer requirements. So here, the customer asks with product companies and consulting companies, the customer doesn't ask. They just do it. They build it. The customer might request consulting services, and then the customer is paying $120 per hour, something like that, right? Right, something like that. But in this particular scenario, with service companies, a service company builds software or applications specific to customer requirement. So customer will say, hey, let me ask for an application to, like I said, rent boats, right? To rent boats. Let me get an application to rent boats. So we would take their idea, we'll design it, right? And then they say, okay, we want the application to have 20 amount of users, something like that, right? Then I will build it, customize it, build an app for it, everything. And then after we have designed it, we'll now deliver it to them, right? So after deliver the product, they will provide warranty. What's warranty? Warranty is saying that this product will last, 8 years, right? We'll provide warranty of the code and support for any bug fixes. Warranty is like hypercare support. So after we deliver the product or software to them, we'll provide 6 weeks of support. After that, we'll provide warranty. It means that if something goes wrong, we'll support it. But we're only going to support it for the next 8 years. After 8 years, it's done. They have to go to the next version. They have to upgrade the software. So customer satisfaction is the main motive in this one, right? This one is the main customer satisfaction. So you're going to work, if you work for a service company like Oracle, like Accenture, Capgemini, Cognizant, these companies, you have to be very, very customer focused. You have to have good customer service. It starts with the customer requirement. The customer says, I want an application. If customer says, I want an application that, has a blue theme, blue color to it, that's what you have to do. You take the customer's requirement, you design it. This is where architects come in. Anytime you hear design, you're working with architects. Then you hear build, you're working with developers. Build is the developer's job. The developers who build, they write the code and they build it, right? And then the deliver piece is the DevOps engineers and the SREs, right? And then the enhancement and maintenance is all SREs. It's all SREs. So Oracle will hire you, Accenture will hire you to maintain applications that have already been built. So you mostly likely going to work for either one of these companies, a product company, where you're gonna be doing a lot of launching and maintenance. You're gonna be at the last step here. This is where SREs are the last step. Or you're gonna be at a service company, where you're doing a lot of consulting or launching and maintenance, or you're doing enhancement and maintenance here. Okay, so you pick which company, which kind of task you like to do. Do you want to work with customers directly? Do you want to work internally within the company? You don't have to do with customers. Or you want to work in consulting where you can, today you're working with AT&T, tomorrow you're working with Geico, tomorrow you're working with Verizon, tomorrow you're working with Wells Fargo, tomorrow you're working with Bank of America. Every 2 weeks or so, you're changing customers because you work in consulting. Consulting is very, very interesting. It's very rewarding. It allows you to have a wide range of experience, because today you're working with Geico, and you for 2 weeks, 3 weeks, you're supporting them for a small short-term project. When you finish that project, they will take you and put you at Wells Fargo for 6 weeks. After that, they put you at, Bank of America for 2 weeks. It's very exciting because you're changing people. I do it. It's fun for me, right? It also makes me work with different technologies as well. Bank of America uses AWS. AT&T uses Microsoft Azure, right? Coca-Cola uses GCP. The state of California uses GCP. So because of working with different clients here and there, I'm learning different clouds as I go, right? So that's what's rewarding about it. But it's not easy. Today, you might work with a good customer who's happy. Tomorrow, you're the government is not very very strict. So you have to be very, very careful with that. Okay. So summary of section 1, what is IT? We saw that. We saw product-based IT companies, we saw consulting-based IT companies, we saw service-based IT company. So that's enough section 1. Any questions so far? Is it clear? It's very crystal clear, right?
Yes, for me.
Section 2, understanding an application. So we've seen that product-based companies create applications, consulting companies help other companies with their applications, service companies build applications customized for customers. So let's understand what an application is and what an application comprises of. Again, basic, very, very basic. An application is a tool. Okay? Give me 1 second here, guys. Somebody send me a Bible verse. We'll see, it's your friend, Tola. Send me a Bible verse. I don't know what's going on. Okay, let's understand what an application is. An application has 2 ways in which you connect, right? Frytime.com has an app that you connect from your phone, right? And it also has a mobile user, sorry, a desktop version. So this Pricing.com, this is the desktop version. But if you go to your phone, it has an app. The app looks different than the desktop version. So, however, all the features you see here are also available on the mobile app as well. Okay? It's the same application. It's just that the way in which you will see it on the mobile app is different than what you see here. You can also open up this browser also on your iPhone as well, or your Android phone in your Chrome or Safari, whatever browser you use. Okay? So this application has two types of users: desktop user, which is this desktop, and mobile user, which is the app. When they connect to pricing.com, they connect to the web server. We have seen this many times, guys. We know this. We know this. We have done it many times. They connect to the web server right here, right? They connect to the web server. So, question for you guys. Who are these people? This desktop user, mobile user, who are these people? Based on what we know.
These people are the clients.
Client.
They are the clients, correct. These people are the clients. The client is connected to a server, a web server. Cool. Now they connect to the web server. If I'm a desktop user, I connect to the web server pricing.com. This is me here. Boom. I am on pricing.com. That's me. The client is Firefox. Connect to this browser. That's it. Done. So now when I'm here, what happens for my request to leave from the web server to here? What needs to happen before it goes here?
I think once a request is being sent to the server checks
To which kind of server? There are many servers.
web server.
Okay.
The web server.
Yes.
It checks its cache. If the IP address is not available, then the DNS resolver will carry the request to the root server.
No. We're not talking about DNS here, right? DNS is a separate process. DNS is completely separate. DNS, there's nothing to do with DNS here. You have your client, you have opened up pricing.com. It has already resolved. DNS resolution is complete. It's done.
Okay.
You are connected to the web server. This is why you're able to see this page. You type www.pricing.com, and this page open. That is DNS resolution. Whenever you type a website and it opens, that is DNS resolution. Let's get it clear now. Let's get that clear. Let's not get mixed up, guys. DNS resolution occurs when you type a website and it opens up. That's it. End of that. It's done. End. Now, I'm saying that right now, I am a desktop user. I'm on a desktop. I am connecting to the web server of Priceline.com from Firefox. So this portion right here, from here, this portion to here is completed. The desktop user has connected to the web server. Now, I have sent a request to here. How do I send a request? When I go to this website and I click on flights, that's my request. My request was sent to the web server, and the web server opened me the flights page. Are we tracking? If I now put the flight from here, if I now do London, Heathrow, and I want to go to Nairobi, for example, Kenya, I do that, and I pick a date like that. When I hit find your flights, I'm sending another request to the web server. My request goes to the web server, and the web server provides me this flight information. Are we tracking? I'm still on the web server. When I go ahead and click this price and click it and click the return and I buy it and I pay for it, that's when my request leaves the web server and goes to the application server. Are we tracking?
Yep.
Yes.
Everything you see here is still on the web server. When I want to buy this flight, when I want to pay for it, I start putting in my name. When you go to checkout, when you want to collect your information and seat map and all these things, That's when your traffic, your request leaves the web server and goes to the application server. When the request lands here now, the application server will now check, hey, let me double check if that flight that Ayamba wants to buy to go to Kenya, if that flight still has open seats. It will now connect the API. What airline is it? Look at that. Advanced seat selection is not included in this flight because it has tried to connect to, what airline is it? Kenyan Airways, and they say seats are not available. So London Heathrow to Jomo Kenyatta International Airport, right? It connects to the inventory system of Kenya Airways. It connects to the international system of Kenya Airways. See, inventory system, Kenya Airways. It connects with API to Kenya Airways to see if the seats are available or if that flight is available. If it's available, it returns back to yes, responds back to yes, it's available. And it now proceeds to check out. Proceed to the next flight to check the seats. Proceed to check the seats like that. Now, confirm seat selection. We're now going to collect passenger details now. Now, your request is now on the application server. Priceline will not collect your information on the web server because the application server is where they will bill you. They will collect your credit card information, your address, your date of birth, your personal information. They're not going to do that here. They'll do it here. So now, when you're on this page and you start putting your information, now your request is now on their application server. And when you buy it and you pay for it, the automation engine fulfills your payment, fulfills everything, and then sends you a response back. Your flight has been confirmed. This is your confirmation code. All that stuff is done. Look at that. Credit card information. Look at that. Monthly payments affirmed. You can pay $60 a month if you don't want to pay for the whole thing now, right? You can pay $60 a month. Billing address. All this information is not collected on the web server, no. The web server doesn't store this kind of information. It's the application server collects it and stores it in a database, like we saw here. The application server collects it and stores it in a database permanently, so that whenever you go back to Pricing.com, you can retrieve, using your confirmation code, you can retrieve your reservation. That is what an application is. An application has a web server, an application servers, and a database. The database is used to store the information permanently. The application server is used to process the requests. If you're buying an iPhone, you can buy an iPhone on Apple.com. When you click on buy the iPhone, that's when your request goes to the application server to buy the iPhone. But whenever you're on Apple.com just browsing, you are only here. That's why when you start clicking buy and buy and buy, if that flight is no longer available, what happens is, if the flight is no longer available, what happens is, when you come in to buy it, it will fail. Because at the if you wait too long, at the 9 minutes, maybe someone has bought that flight. Maybe there was one seat left. Somebody bought it. And when you click on proceed or buy flights, it's no longer available. It will keep failing. Book and pay, and it's no longer going. So when you book and pay, these requests that you're clicking here is on the application server itself. Also, if you have an account with Priceline and you come and you log in, you sign in. When you sign in, everything you're doing is on their application side because you have an account with them. This automation engine here is the automation that collects your credit card information, books your travel, creates a book confirmation code for you, all that stuff, fulfills and send it back to you. And then sends you a notification, email. But the billing system collects the payment and everything. So this is how the application works. Application has a web server, application server, and database. Any question on the business application? Same thing happens on the mobile app as well, right? The client sends a request to the web server. Web server shows you the website, shows you information on the website. And then when you buy, once you buy, your request now goes to the application server. Any questions, guys? Ask. So let's break down the application, right? Let's break it down. If you look at this application here, the web server is a front layer, okay? Something called back end and something called front end. Let's break it down. This is very important, guys. Please ask me questions if you don't understand. The front layer of an application is right here, the front end. You have the mobile user, you have the desktop user, you have the internet. They connect to the load balancer. The load balancer takes that request and sends to the web server. Well, I will argue that, oh, where's the load balancer here? Well, for simplicity, we did not put the load balancer. But know that every request going to an application goes through a load balancer. Have that in your mind. It's permanent. Every request that goes to an application goes to a load balancer. Here, we didn't have it here because one just make it simple, to simplicity. But now we're going to start breaking down into what an application really is. It's a load balancer that receives requests. What is the use of a load balancer, guys? What is the function of a load balancer?
To distribute traffic request to
Yeah,
different servers.
guys, your answer should be concise, complete, and concrete. Your answer is concise, but it's not complete or concrete.
See, the function of a load balancer is to redistribute traffic requests to various servers to create
Various
efficiency.
web servers.
Web servers, sorry.
There you go. Your answer is now complete, it's concise, and it's concrete. Thank you. The web server is used to distribute requests, traffic requests from clients across multiple web servers or multiple application servers, because a load balancer can also be in front of a application server as well. So in this case, the traffic comes from the desktop user or application users to the internet, it goes to the load balancer. The load balancer, the desktop user or mobile user, what do they have to do? They have to authenticate. What's authentication? Give me 1 second. What's authentication, guys? What is authentication? Hey, we learned it yesterday. What's authentication?
Authentication are credentials that we use to access an application or a server.
Yes. Close, but not complete. Concise, but not complete.
For me, I think authentication is a process of the system checking your credentials, making sure that they are correct.
Yes, it's concise. It's not complete or concrete. What is authentication? We did it already. Did you guys have that note that we did? We did it on Monday now. Did you guys study? Is anybody studying? We did it on Monday. I'm surprised, man. Oh my goodness. You guys will be okay. Be all right. You have to study. This is school. This is like university. You have to study. You have to put your foot in a bucket of water and study. What's authentication? Can somebody just read it for me, please? Just read it. Just read it. Just read it, guys. It's right there in front of you. Okay. Don't worry.
You use IAM to control who can use your AWS resources.
So in this application, what's user authentication? This desktop user or mobile user are trying to connect to this web servers right here. So they have to log in. If it's Priceline.com, they have to log in. Authentication is pretty much access to the system. You have to log in using your username and password. You have to log in using your username and password. Right? Right? You have to log in using username and password. So user authentication is a process of logging in to the server using a username and password. That's what user authentication is. Right? Okay. So the front layer is the web server layer you see here. You have this CDN. CDN stands for Cloud Distribution Network. Because there's content is like, for example, let's use Netflix. There's content that we need to be able to see from the web server, the website. Like here, we need to be able to see this content for Priceline.com, this content. We have to serve that content using a CloudFront distribution network, right? So the CDN. So that's static content. These are all images. These images you see here are permanent. If you come back tomorrow, you see this image here. This woman doing this image. It's Halloween is here now, so we're using this image. So this content that you see on this page is static. It doesn't change. So we have to serve that content to the customer somehow. That's why we're using this CloudFront distribution network. So when users connect to the website load balancer, they are here. They can see the static content. And then when they want to buy or buy some solution or something, want to buy the flight, that's when now their request now leaves there and goes to another load balancer or an API gateway. An API gateway is similar to a load balancer, but an API gateway is specific for an application. Okay? And then it goes now to the app layer. So the front end is the web server layer and everything in the front. That's the front end. So the front end is direct customer interaction. Whatever the customer interacts directly, that's the front end. It's internet or intranet accessible. So internet means that these users can access it over the internet. And then us as SREs, we can access it through the back. We can access it to the intranet. That means if we work for Priceline.com, we can access this application. We can access the web server within our Priceline.com network, within the internal network, which is normally VPN, within the VPN network, right? Within the company. It's called intranet. Nowadays, we don't call it internet anymore, right? We call it VPN. That's what that's replaced with. The company network is called VPN nowadays. It's no longer intranet. This is a very old name. So you replace it with the word VPN. Okay. So we connect within the company, like we're connecting to a server, right? We're not connected to the server directly and work on it. But the users that use it connect over the internet. So the front end is everything web layer. We'll go back here to my old diagram here. The front end is right here, the web server layer. That's the front end. This is your front end. This front here layer. That's it. So whenever I hear front end developer, it's a web developer. Whenever I hear front end developer, it's a developer. If I hear front end architect or front end engineer, it's somebody that only works on the web server layer. Okay. Any questions on this? I hope you guys understand it. Nobody's asking me questions. User authentication to block fraudsters. So you have to make sure that users are able to authenticate, that people have accounts and then authenticate using their accounts so that you can block fraudsters. Okay. And then you have the CDN, the content delivery network for high performance. So we use that to serve these images, right? This image is for high performance, so that when you click on cars, it's fast. Click on airports, you type DFW airport, it's fast. That's what content delivery network helps you with, right? And then the distributed traffic hits web servers through a load balancer. So all the traffic from mobile users, desktop users, they go to the load balancer, and load balancer will spread the traffic across server 1, server 2, server 3, right? Even if you click on the same website at the same time, we may not be on the same web server, right? The load balancer spreads the load all the time. It's always doing round robin. So the first traffic that comes will go here. Second traffic will go here. Third traffic will go here. Fourth traffic will go dark number 1. Fifth traffic number 2. Seventh traffic number 3. 8 traffic number 1. 9 traffic number 2. 10 traffic number 4. It's just going to keep rotating like that. It's called round robin. Load balancer is a round robin device. Round robin. If you want to take notes on that, right, you can take note on that. A load balancer is a round robin device. A load balancer is a round robin device that spreads traffic requests across multiple web servers. So load balancer is okay. So an API gateway process on the customer data based on system design. Like I said to you, right? Customer data, customer information is not stored in the web server layer, right? When we want to buy the flight or book the flight or whatever we're trying to buy or do, or put in our address, our credit card number, that's customer data. Okay? That's customer data. That customer data is not stored in the web server layer. The request leaves with that customer, leaves from there and goes to API gateway, will collect it and pass it on to the application. The application layer is what processes the customer data and then sends that data to the database for storage. Okay. Any questions so far on front end? Okay, no questions. I guess it's easy. Application layer. So you have the front end that we just saw. That's the front end layer, right? Now we'll come down to the application layer now. The application layer is the business logic, is the workflow, is the where the business actually happens. It's where the processing of your credit card and the flight purchase actually happen. Guys, I'm using pricing as an example, though. It's not only pricing that exists. I mean, this is just an example. There's many, every company has the same logic, the same structure. It's called a 3-tier application layer. Tier 1 is the web layer, tier 2, and then tier 3 database, right? So the application layer is the most important layer. This is where pricing.com will now process your credit card, book your flight, create a confirmation code, and then save your information in the data layer. All right? And save in the data layer. Okay? So, I swear I'm so hungry. In this application layer, you have a workflow manager, okay? That handles things that come in order. So you send your request to buy a flight. Isabel sends her own, Chris sends his own, Kobe sends her own. The workflow manager processes the orders based on how it came in. It's called first in, first out, FIFO. It's called first in, first out. That's the logic. First in, first out. The request that comes in first will be processed first to the next person. If you're not trying to buy the same flight at the same time, whoever clicks book and pay first will book that flight. If you're the one to sit left. Okay, so this application layer has interfaces with other applications, right? Like I've mentioned, right? If you use Affirm, Affirm is used for payment plan when it comes to buy now, pay later. So Affirm is interfacing integration with Affirm to pricing.com. You have Stripe. It's used to process credit card information. You have an integration with that out here, API integration, right? And then when they're done, they store the reservation in the data layer. Okay. So what happens to the application layer? It collects data from the front end and processes it based on the business logic. The business logic could be anything. For Priceline, is buying flights and processing your credit card information. For Amazon.com, is pretty much fulfilling your order, right? When you buy things on Amazon.com, it will fulfill your order and send you a credit card. It will send you another number. Your order has been placed, right? So there are many different business logics. The business logic is specific to that company. Any certificate or mechanized ID or password used in the application are configured in the application layer, right? So any users that need to create a login, like let's say when you create a login here on this side, to create a login here. This login, your username and password is not stored in the web server layer. The application stores it because it's a Priceline application. So you want to create a username and password, guess what is created on the application layer, right? So any certificate or mechanized password is in the application are configured in the application layer. The workflow manager acts based on the business logic. It acts based on the business logic. The business logic says, hey, process this credit card, do this. That's a workflow. It will process the credit card, book the flight, create a confirmation code, and then notify the user via email. That's 4 things that the manager has to do. So that's a workflow. You will perform all those 4 steps. Accordingly, interaction with interface applications take place. Because Ryerson is not a credit card processing company, they use another company to do their credit card processing. They use Affirm for buy now and pay later. They use Stripe, right? They also integrate with other airlines as well to get the most up-to-date information about airlines. They also integrate with other hotels as well to get the most up-to-date information about hotels. That's why when you check a price look for a flight on here and you see a specific price, go check that same price directly on the airline and compare. One of them might be behind, right? If the price on here is $400 for the flight, and you go check the site, it might be cheaper on the direct side itself because they haven't updated pricing.com, right? The updates it doesn't run every minute. Right? So the processed customer data is now stored in the data layer. So when they're done processing the credit card information, all that stuff is now stored in their data layer permanently. That's why when you go back to pricing.com and you want to check your flights, you put your confirmation code and your last name, and it will retrieve from the database and show you on your app. Any questions, guys, on this application layer? I'm worried that everyone is quiet. Are we understanding it? Is it clear? Okay. Back-end jobs. Now, there are some jobs that I just mentioned, right, that occur in the back end that does things. For example, 400. Sorry. So there are some jobs that happen in the back end. The back end is simply everything behind here. Let me show you guys this diagram. The back end is everything behind here. From here going down, the back end. The application layer and the database layer is your back end, while your web layer is the front end. Okay? Front end is the web layer. Back end is application and database layer. That's it. So there are some back-end jobs will happen between the database and the application. For example, there are some scheduling jobs that occur that whenever you buy your flight, I'm using the Pricing example, but there are many other companies that we can use, but I'm using Pricing because people travel, you understand pricing.com easy. The back-end job, when they process your request to buy a flight, they book your flight, charge your card, pick your seats, create a booking confirmation code for you. They have to send an email to the user, right? Remember that email that you received, that email that comes to you, your booking confirmation code and everything, and your receipt? That email comes to you. So that back-end job, a job is simply a workflow, a task. A job is just a task that the computer does it for you. And a system user, not a human user. A system user is automated. Every time that a flight is purchased, email the user their credentials. Sorry, not credentials, their reservation confirmation code. So this backend job takes that, sends an email and sends to you. Done. And then installs the confirmation code in the database. And then it writes to the file system. It writes the raw code file to the file system, right? And then there are some reports created and then data analysis for BI, for business users to do analysis on how much did we sell in flights this month? How much did we sell Delta flights, American Airlines flights, all that stuff. This is analysis that they're going to perform. So scheduled jobs run to collect customer data for further analysis or processing. Those scheduled jobs are the ones that collect your name, date of birth, credit card information, and pass it to the application layer to process it, right? And then the scheduled jobs as well send the output. Your flight has been reserved, your flight has been conserved, booked. Sends the output back to the customer, either by the same flow or how the data flew in, or depending upon the architecture. We prefer email. So the flow, the job will send an email to the customer with their reservation confirmation code, right? And then that same job stores the customer data in the database, right? And then several types of reports are generated with the process data for analysis and business improvement. The job also creates those analyses, right? The data analysis for several purposes is done. So those jobs in the back-end layer, which is the application database layer, are very, very important. We are not going to configure those jobs. Hello? We are not going to configure those jobs, but we are going to maintain those jobs. If a job fails to run, for example, user bought a flight, the job fails to send an email. We're going to, since we're monitoring the whole flow from end to end, from when client connects to when client buys the flight, we're monitoring everything, we are going to know, we'll see an HTTP 505 error or something like that. We'll see something like that, right? So when we see an error like that, we'll know what to troubleshoot. Either we'll escalate, we'll inform the stakeholders, we'll inform everyone in the company, send an email out, or we're going to go try and rerun the job. If the job is not running, we can restart the job. So we'll learn those things. How to restart a job, how to fire a job. There's something called cron tab in Linux, how to fire a job to run, right? So those are things that we'll see. So examples of application, let's look at an online ticketing booking portal. Like Pricing.com is a booking portal, right? The user view, the user is the user, people that buy flights online, not me and you. Me and you was SREs. This is the user's view, the user that want to buy a flight. The customers that use Pricing.com to buy flight, the users. Me and you, we are SRE users, not the users. We don't buy flights. We go into the system and create systems and maintain the systems and monitor it. Users buy flights online. So this is their view. This is what they see. On the online portal, which is the website, they see number of passengers, days of travel, they see deals, which is here. They see deals, they see number of passengers, right? If you do flights, number of passengers, economy class, this is what they see. This is the online portal, right? And then when you select their flight, it goes to the next page. They see different flight options, flexibility to change dates. Let's do that. So we come here, we choose DFW or London Heathrow. We're going to Nairobi, Kenya. Choose the date. And we choose find your flight. And you see the different flight options. We have a flexibility to change the dates. You see? We have flexibility to change the date right here. You see that? We can change the date right there on the screen. Right? And then here now, that you now click next, choose the flight, you click next. You now have to enter your travel details, name, age, email address, registration address, right? Then after that, go to your payment page where you put your credit card details and billing address. Then you get a ticket confirmation. So that job, right? That back-end job is the one that's doing all this work. The back-end jobs collects your name, age, email, and information and sends to the application server. It also collects your payment credit card information, sends to the application server, and then it generates a ticket confirmation, store your reservation in the database, and then sends it to you, confirmation email, and send you an email that your flight has been booked on it. That's it. Right? That's what happens. This is the user's view. Our view as SRE engineers, as site reliability engineers, this is what we see on the back end. When we log into the servers, the web server, the application server, the database server, this is what we see. We see the user logging in and their encryption, their credentials, but it's encrypted. We can see what time they logged in. We can see from where they logged in. We can see their IP address. We can see they're using a secure browser. We can see their HTTP code. We can see the database health. We can look at the malicious traffic watcher to see if there's any kind of malicious traffic. We can see the content delivery network that is being used, serve that application. In the select flight page, behind the scenes, we are looking at the updated catalog of flight and pricing. This is when the Priceline.com needs to connect to Delta and American Airlines and pull the updated catalog of their flights in real time. We can see that in the back end. The web server response time, how fast, you have a monitoring tool, right? We're looking at our monitoring dashboard, looking at the response time. How fast is the web server responding to the clients? We are looking at this metric. This is a metric that we'll look at, that we're going to monitor. Database health. How fast, how much is the read throughput to read from databases? How much is the write throughput? Right? Application components, microservices health. How fast is the application responding? That's all we care about. On the travel details page, address validation. We have an integration with the United States Postal Services. When the customer put the address of their credit card, we'll run the address through the USPS API to make sure it's valid. That's how when you put the wrong address and wrong zip code and the credit card information, it fails because the credit card doesn't match the address on file. On your bank account, you have a credit card information and they have your address. They have mapped your address to your credit card. So if you put your credit card information and you don't put the right address, because of address validation tool, it will fail because this is an external integration. Then we also see the HTTPS code, database health. We also have to follow this compliance, which is a payment credit card industry compliance that we're able to encrypt your credit card information. Your credit card information is not supposed to be shown in clear text. You're supposed to hide all the letters, the numbers of the credit card, and only show the last four of the credit card on the system. So that's the encryption and decryption part. Okay. And then on the payment side, credit card validation. Whenever you put your credit card information, since we're using Stripe to collect payment cards, Stripe has an external integration with Visa. If you're using the Visa or you're using MasterCard, right? You would check if it's the Visa or it's a MasterCard or American Express. So you have to do the validation. You have to validate it. You will check against Visa or against your bank to validate your credit card is correct. Then you connect to the payment gateway. The payment gateway here is Stripe. It connects to Stripe. And then it gives a response code of success, HTTP code 200. Database health is now checked as well to see if we can store your credit card and your credit card information in the database with your reservation and everything when you're done. Then again, we're also following this compliance here to encrypt your credit card information and decrypt it. And then the application health as well for the microservices. Microservices is simply the specific service that you're buying. If you're buying flights is a microservice within Priceline.com. Priceline.com has hotel, flights, cruises, different things. So flight is one microservice Hotel is one microservice, but pricing.com is a whole platform that has many, many microservices. So flight is one service. So if you're buying flights, we also need to monitor the health of the flight microservice. Okay. And then when it's done with that layer now, we can also see the ticket confirmation, connection with the emailing or texting system. You get a text message, right? They use something called Twilio. They use Twilio. Twilio. It's a text messaging service used for sending text messages to customers, Twilio. So they use that to send confirmation and email text messaging. Again, that job, don't forget, guys, that job is what's doing this in the back end. This back end job. You're not the one doing it. You're not the one. This job is automated and created. That's why you see here in the application, it shows automation. Automation in the engine. Go ahead, ask a question, Kwasi.
No, exactly. That's the question I wanted to ask, because I was feeling like going on the website and doing that the way it's going fast. How a human being can do that?
The job, the back end job, guys. It does all that for you. The back end job is checking all these things. All these things. We are only monitoring. We are monitoring these things. We are monitoring the database health. So on our dashboard, come on, guys. On our Datadog dashboard. Oh, sorry. What is happening here? Datadog dashboard. Let me just show you an image. Use what you'll be seeing. We're monitoring. You'll be seeing something like this on the dashboard. We're monitoring the database, memory, CPU, storage. That's what we're monitoring, guys. The database health. So when you start seeing red here, you're not always affected. If it's green or it's blue, then it's good. So all these things like that affects the application, we are going to monitor it. Mostly database health, application health, microservices health, right? There's HTTP status codes, right? The external integrations, we're going to monitor that stuff. We're going to monitor the malicious traffic. We're going to monitor web response time, database health, application microservices. Not many things that are going to monitoring, right? But on the database health, we're monitoring memory, monitoring CPU, monitoring storage, read throughput, write throughput, latency, right? But they're all automated. Once you install the log agent on the servers, they collect the logs for you and push it into CloudWatch, generates a dashboard, and that's it. You don't have to worry. That's all. We'll just monitor. When you see an issue that is happening, we report the issue. That's it. Okay? And then, again, like I said, we're monitoring database health and also application microservice health as well. So there are common things that we're going to monitor, common things, the same thing over and over. But we're also going to monitor the job. We're going to monitor the job that does these things as well. If that job fails, these things will not happen. Customers will not be able to. If that job fails, customers will not be able to buy flight online. If the job fails, right? If the job fails, customers will not be able to buy flight online. So we need to monitor that job as well. And then now that job will also send an email or SMS, which is the final order confirmation to send to the customer. That's it for an online booking portal with the SRE. That's what we'll monitor. Any questions so far? Yeah, question, go ahead.
I want to ask a question about the CDN. Is it the same CDN you have seen on the... Okay.
This is the networking monitoring. We'll monitor this network of this, but that's about it.
Okay, because the first time I was thinking you say cloud distribution network. That's why I was confused.
Yeah. I made a mistake. Sorry. It's content delivery network. Now, so there's two different CDNs. There's content delivery network and there's CloudFront distribution network. The CloudFront distribution network, it's a service. It's an Amazon service, right? AWS service is called this one right here, AWS CDN. Amazon CloudFront is a service. So within Amazon CloudFront, you have content delivery network as well. All right. So that's that for an online booking portal. Let's take an example of an online shopping website. We only have 2 minutes. Let's just go, or 12 minutes. An online shopping website, this is what the users buy. Let's say Macy's, Nordstrom, Amazon.com. This is what the users who buy, this is what they see. On the online portal, they'll see the products and the ratings of the product, customer reviews. When they select a product, they'll see the product details, delivery options, customer. Let's say Amazon.com. You see the product listing and the customer ratings. When you select a product, you see the product details, delivery options, customer reviews. And then when you click on the product and add it to your cart, you do a checkout, you select the items in list preview, right? You go to your cart, you see in list preview. And then when you now click on now checkout or place on the buy, you now ask you for your name, your address, the preferred timing of delivery. You select all that, you go now to the next page, you put your card details. And then your billing address, you put order in there, and then you click place my order. And then that back-end job will now collect, the back-end job has collected all your information, right? Collected the products, your name, your address, the card and billing, that's put it on the application server will process it. Now the back-end now send you a confirmation email. Your order confirmation page, final order confirmation is sent to the customer, right? Like that, right? That's how it works, right? But again, this is the user view, right? This is what happens when the user see. The user see order confirmation page. Find out, then they're gonna receive an email and SMS sent to them. This is what the users see. This is what we see. We see how much time it took for that user to get a response when they click that product. When they click on the product, we see how much time the web servers responded to show them the product online. We see if their connection is secure. We see the updates of the products that are updated every time. We see the customer's data encryption. We monitor the database health. We monitor the malicious traffic watcher. When you select a product, we see the response code. Every time a customer clicks, we check the response code because we want to know how fast those clicks are. And there's supposed to be at a specific level that we're going to determine. If it goes below that level, then we need to investigate what happened. If customers say, oh, I'm clicking on flights, car, and it's taking forever to open, we need to start investigating because we know in our monitoring tool, we see what? We see HTTP response code. So that's the metric we're going to go check. Normally, it's supposed to be 10 milliseconds. That means 1 second divided by 10. So when you click here, that's 1 second divided by 10. That's how fast it's supposed to be. Anything below, less than that, we have to investigate why it's slow. Kwasi, go ahead, yes.
HTTP response code is what you call last time latency, right?
Yes.
Or is different?
Yes, latency, yes.
Okay. Just to make sure.
Good question. So when they select a product, we check the same, we're monitoring the same things. They check out, same thing we're monitoring. Delivery details, or checking the same response code, database health. But here again, whenever you're putting your address, right? Whenever there's address involved, there's always what? Address validation. So there's an external integration with the United States Postal Services for that, right? And then you have the PCI data encryption as well here to store or encrypt your critical information. And then we're also monitoring the application health and microservices. Since Amazon.com is a platform, it has microservices. You have Prime Video, that's one microservice. You have pharmacy, that's one microservice. You have different things. Amazon Music, that's another microservice. So we're monitoring those different microservices. And then when the users put their credit card information, when the user put their credit card information, right, there's also what? Credit card validation. And then also address validation as well. And then we'll also see the response code, we're on database health, encryption, and microservices. Database is very important because database is what stores information about everything. So without the database, nothing happens. So I must monitor the database health very, very much. For the application on the web server, I'm monitoring their performance by monitoring what runs on top of them, the microservices that runs on top of them, the memory, the CPU, the storage, the latency, those things, read throughput, write throughput, and those applications on the web server. But for database, we're monitoring more than just CPU and memory. We're monitoring the database response time, which is the read throughput. We're monitoring the write throughput. We're monitoring the read latency, monitoring the write latency. We're monitoring the database response time in terms of how fast it responds to a user request, right? And those things. So we're going to be creating the monitoring for database dashboard. We'll have all the monitoring for databases that we use. Okay. And then now we also see the connection with external email or texting services like Twilio to send text messages to the customer that your order has in place. Here's your order number, all those things. Again, that back-end job, the back-end job is what runs to create that confirmation code, emails you, do all those things. You don't do it manually. We just monitor that the job is doing its job. No pun intended. We monitor that the job is running and doing its task. It's collecting customer data, processing customer information, doing card validation, all these things. While monitoring that it's doing, if it doesn't do a specific step, then we step in. That's our job as SRS. We're monitoring all these tasks. So that's what SRS is view for an online shopping website. Any questions? An application, entertainment website, so like Netflix, this is what the users view. The online portal, they have the videos category. You have action, you have sci-fi, you have comedy, you have romantic movies. Then you see the movies, the list of the movies and their ratings. When you select a video and you click on play, it will play. And when it plays, it goes, the back-end job goes to that movie file where it's stored, and go retrieve that file and play it for you. And the web server now responds to you with the movie and you see it play. So the users see what they see: monthly subscriptions. You can add multiple users to your account like Netflix. They see user-specific watch lists. Let's say you're in UK. You see a specific watch list only for UK. Customers in UK see things different in Netflix than we see in the United States, right? Because of cultural differences. Some movies that are shown in the United States cannot be shown in the UK because of cultural differences and regulations. Then you will see your watch history. And then Netflix also does recommendation as well. Recommend you movies. If you don't know what to watch, it will show you recommendations. That's the user view. On the back end, what do we see? This is what we see. We see the API response time. When you click the movie How long does it take before the movie plays? That's what we see in the back end. We see the content delivery network that we're monitoring. We see application and microservices health. We see database health that we're monitoring. We see infrastructure health. We see user data encryption. We see response code. Similar things. Every application is similar thing. Database health. There are similar things that we're going to monitor. And that's why this job is easy, because you can learn all these things and you can work for any company. All companies have monitoring. All of them have it. So you can go work for Geico or State Farm or Verizon or Wells Fargo, and you'll be monitoring the similar things. That's why the job is so easy, guys. You're monitoring database health. You go to the next company, you're also monitoring database health, because it's the same. All companies have databases. Okay? Any questions? Social media site. This is what the user sees. Social media, they see their profile, they see social profile, they see their personal profile, they see the content upload, they can look. Let's say this is Facebook. They have a personal profile, social profile, they can upload pictures, they have Messenger, they can watch others' contents, they can comment or like others' contents. That's what they see. It looks very basic. This is Facebook, very, very basic. They can like, they can put emojis, very, very basic. On the back end of Facebook, this is what we see. We see database health, which the database serves information to Facebook. The pictures are stored in the database. We see the data encryption for users. We see the malicious traffic. Same thing, with API response time. When you user click on a picture on Facebook, how long does it take to load? So similar things. Okay? A banking portal, the banking application. When the user sees their account, they see the savings account is checking account. You see their credit card, the travel card, no annual fee, low rate card. They see their banking transaction, account summary, they see third-party transactions listed down there. They see their loans, they see their home loan, they see their car loan. They see their insurance, they see home insurance, car insurance. They see their savings and investment plan, they see tax savings fund, retirement fund. That's what they see in their account. In the back end, this is what we see. We see database health, we see encryption. Remember, this is security, right? So we're monitoring that the data is encrypted at all times. We have to make sure that customer data is always encrypted. So we're monitoring the encryption cycle. That job, that back-end job, is supposed to run encryption on every customer data that it collects. It's supposed to encrypt it. So we're monitoring that job is doing encryption on all customer data. We're monitoring database health. We're collecting logs. We are monitoring application and the microservices health. We're monitoring the API response. How long does it take when you click on credit card to respond back to you? We're looking at the firewall. Since it's a banking environment, there has to be a firewall that protects the internet to the credit card, the banking accounts. And then connection with third-party systems. That sends you a text message. If someone uses your card unauthorized, it'll send you a text message and all those things. Right? Monitoring those things. So that's that for a banking portal. Any questions, guys? Utility app where you pay your bills. Let's say your water bill. You have the home page. You have your profile with your account number in there. You have the product catalog. You have promotional offer. You have your usage detail, how much water you have used, your personal details, your payment card information, your product. Select it. You want to buy electricity or buy water. Right? That's what they see in the utility app. In the back end, this is what we see. On the home page, response code is very important. API response, application health, certification of the app, which is what? Which is security. User profile, data encryption, API response, connection to international services, product catalog, of the data catalog, API response, database help. Same thing here, promotional offers. The offer should be updated at all times, because if a user comes in and click on the offer and the offer is no longer there, then it means that it's expired. That's what we see in the back end. Summary. What's an application? Front end layer, application layer, and back end jobs. Questions? Are we understanding these things, guys? This is very theory. We're going to get into hands-on after we're done with this portion of the course, but you need to understand what you're doing, what you're going to be monitoring. You need to know what you're going to be looking at. You need to know what's important in the business, right? Okay, so on Monday, we'll continue session 3 to learn what types of users exist, okay? So we'll stop here today. Any questions, guys? I'm worried though, we're not talking